Welcome back. Let's learn about how you can create a face recognition application using Azure Face Services. This service provides you the AI that detects, recognizes, and analyzes human faces. Without any further delay, let's go ahead and see how we can build this. I'm currently logged on to the Azure portal and inside the marketplace. I'm going to quickly hit the search button here and type face and then just select the first option, then click on create. As always, I'll go ahead and select the right subscription, create a resource group, and then type the name as well. Raining Face should be okay, just being creative here. Now, from the cost perspective, we need to make sure that we have the right pricing tier. Now, what we are doing is just a proof of concept, so I'm okay with the free F0 option, but in case of production grade applications, make sure that you select standard SO, which will give you far more number of API calls allowed on that pricing tier, right? The next option is kind of important here, where you certify that you're not using it for any police department usage in the United States, right? So the checkbox clearly states that. So give it a read and comply to that. For now, I'll go ahead and just check this box and click on next. I'll also skip the tags option and click on create for it to validate the settings and let it create a face service, a face cognitive service for us. So once the page is ready, you will see a screen that looks like this. In the quick start, it tells you that you got to get the API keys and the endpoint to authenticate your applications, right? That's very important because if you're deploying, let's say, a Visual Studio Code, you need to have the API keys. Otherwise, how will it authenticate? How will it know what endpoint it need to query, right? And you can get the API keys and the endpoint from the next section, which is keys and endpoints. Well, let me tell you that even before we get into the keys and endpoints section, there's something important here because you need to install some libraries. And to do so, I need to launch the command prompt, and I will show the method in a minute to you. So what I have to install is a cognitive services vision face. And command to install that is pip install hyphen hyphen upgrade, and then you put that string there, which is Azure Cognitive Services Vision Face. And yeah, of course, you got to have PIP installed on your computer, which is a Python package manager that lets you install the libraries and dependencies for a particular application. So we just say PIP install, and we are upgrading it to have that particular library set. Now, in my case, it already has all of those libraries installed, but I'm telling this to you so that I don't want you to just go ahead and launch that Visual Studio and bump into error messages. But just in case if you ever bump into those error messages, this could be the possible reason. But wait a minute, we also got to install something else. It's called as Pillow, right? Interesting term here. So we need to install the Pillow libraries as well using the command pip install Pillow. Pillow is also a Python library, and we need that for our Visual Studio Code to be executed properly. Now, in my case, again, that is already installed, so make sure that you make a note of both of these commands in a separate notepad and execute them one by one. Now I will launch my Visual Studio Code, and as you have already noticed that I already have the code written into it. Now you can of course download this from the resources section and copy and paste it here, but it's important to understand what this code is doing, right? Alternatively, you can also find this code in the Microsoft documentation. But there's a small heads up that I want to give that at times your libraries that you've just installed on your computer are not detected. So if you look at line 13 through 15, it has not detected it because I have said from azure.cognitiveservices.vision.face, but it looks like it's not able to find the cognitive vision APIs in the right set of libraries. So what I've done is in line number 2, I've added assist.path. So it's more like an environment variable. So when the script gets executed or when the code gets executed, it's going to go and check in that path in C, Python 36, library, site packages, where the code should be able to see and identify where those pillow library is, where the Python libraries are for this code to be executed properly. Now, let's go back to line number 18. You see key, and there's line number 21, there's endpoint. And these terms may not be new to you now. The authentication is done with the help of keys, right? So when the code gets executed, It needs to know where is the face recognition API, where is it located. It also needs to get authenticated with the key that's there inside the face API. All right. So now I'll go back to my Azure portal, pick up the key and endpoint, and just copy and paste it from there. There you go. So I'm going to pick up the key 1 here, and then I will paste it there. I will also copy the endpoint and paste it also in the Visual Studio Code. So that's how it's going to look like at the end of it, right? So line number 18 and line number 20 is ready, it's filled up, and now we are ready to rock and roll to execute this. But wait a minute, let's go and take a look at the other options that you see from line number 26. I just want to take a moment to explain the various options and the controlling behavior of this code. Now, in line number 24, we are just saying that, hey, you got to go and use the following endpoint. And here is a key to authenticate yourself. Now we are storing all of that in face underscore client, yeah, and we can use that further in the code. That is the first step. Line number 27 here just tells us where your file is, where is your image. Now, as you see, I'm looking at the GitHub documentation from Microsoft, going into a folder called as master inside cognitive face windows. There's a file called as detection1.jpg in data. Now, if you navigate to that path, you will see that there are a lot more pictures. There's detection2.jpg, there's detection3.jpg, there's 4 and 5 as well. If you click on those individual pictures, it will show you pretty faces. There are group pictures, there are single photographs as well, there are puzzled images, there are faces that have certain emotions, probably they are puzzled, and that's the job of the face detection to identify whether they are happy, what their age is, are they smiling, and probably what their emotions are. So the single face image URL is the path where the image is located, right? Now moving on to line number 31, which is using a detection model tool. I'll talk about that in a minute, but it just says that there's detection underscore faces, which is using the function face client face detect with URL, and the URL is mentioned in single face image URL, which it picked up from line number 27. Now, if you notice carefully, it's using a detection model called as detection02. Now, this thing brings a thought in my mind that is there something called detection01 as well? Is there something called as detection03 as well? Well, there's nothing called 03. You got just 01 and 02, but it's important to know the differences. Let's talk about it. Let's talk about it and understand this with a presentation here. So here is the difference. There's detection01, which is a default choice for all face detection operations. But detection02 is something that you gotta specify explicitly. Now, detection01 is not optimized for small or if the picture has a side view or if the picture has blurry faces. But 02 is then more optimized for blurry faces, even if the picture is small or if the picture has side view, it's going to get that accuracy. Now, the face has several attributes, right? The face attributes could possibly be the eyebrow color, the eyebrow liner, the eyes and the eye color, the length of the nose, the upper lip, the bottom lip, mouth right, and how much to the left the mouth is, including the eyes. Now, if you got to focus more on the eyes, we can then look at pupil, where is the pupil located, etc. And there could be numerous points that it looks at. Now, that's what's called as landmarks and attributes. Now, there are multiple attributes that it looks at. Basically, the face detection 02 algorithm will look at 27 predefined landmarks. So when we are using detection 01, it is very good at identifying the landmarks plus the attributes like age, the blurriness of the face in the image, the emotions like happiness, sadness, neutral, anger, disgust or surprise and fear can easily be identified with detection 01 algorithm. How about facial hair, gender? Does the person have glasses? Is that a reading glass or a swimming glass? Is that a sunglass? How about hair? Does the person have hair? Are they visible? Is the person bald? Or are there any colors in the hair? What is a head pose? For example, what is the orientation in 3D space like 90 degrees or minus 90 degrees? Is there a makeup? Is there eye makeup? Is there a lip makeup? Or is there a face makeup? What about the noise ratio? Is there a smile? So this kind of detection, so detection 01 can give a number, for example, 0 for no smile and 1 for a clear smile, right? So detection 01 is very intelligent. 02 is also good, but it does not return the face attributes and face landmarks. So now I'm back in the code here looking at line number 31. We can flip it between 01 and 02. Now, I just want to detect the face in the image, and that's the objective. I don't want to know the age of the person, or let's say the objective of the project is not to know any landmarks of the face, so let's keep it easy and simple and set it to detection 02. Now, what should it do if there are no faces detected in the picture? What if it's an image of a park with lots of flowers? Then what should it do? Now that's determined by line number 32. So if no faces are detected, then raise exception. No face detected from the image, right? And that is pretty straightforward. And then if the face is detected, what should it do? That starts from line number 36, which tells that identify the face and draw a rectangle all around the face. And that's from line number 36 to line number 43. Now, as you see, there's a method called as getRectangle, which is being used to draw that rectangle. Now, we're just trying to get that image, which is downloading on your local machine to process it and then show it up as well. Line number 52 draws the image. Line number 53 tells where to draw the face. So for each face in detected underscore faces, it's going to draw a rectangle which is red in color. Of course, you can change the outline and put it to your favorite color or something that matches the background of the image. And finally, line number 57 is to show that image up on the screen. So now I'll go ahead and click on the play button or the execute button, which is there on the top right hand side. And you should be able to see the output in the bottom pane. And there you go. You see certain output, that drawing rectangle around the face, and you see the pop-up for results. And here you go. You are able to see that red rectangle. Looks like a square to me at least, but it did draw and detect the face in the picture. So we have successfully recognized the face in the image. Well, that's the end of this lab demonstration. In this lab, we were able to look at the Visual Studio Code, run that program, which is able to pick up the various face recognition Python libraries, call them, and then draw a rectangle after it could identify a face in the image. For demonstration purposes, we picked up these images from the Microsoft GitHub repository, and I'm going to put this code and everything that's required for you to do this yourself in the resources section. Thanks for watching so far, and I'll see you in the next lesson.